So hi everyone, welcome back to another video on the channel. In this video, we are going to discuss another problem in our DSA series. In the last video, we have discussed how to check whether a number is prime number or not. And in this video, we are going to discuss how to find GCD or HCF of a number. GCD stands for greatest common divisor or highest common factor. I think everyone must have studied this in school. Uh, so let me just give you a quick recap of what a GCD or HCF is. So consider two numbers, 12 and 9, and find out the factors of both the numbers. The factors of 12 are 1, 2, 3, 4, 6, and the factors of 9 are 1, 3, and 9. So what are the common divisors between both of them? First one is 1, and the second one is 3. So GCD or HCF is nothing but the greatest common divisor between two numbers. So here the greatest common divisor is 3. Please remember that in case of prime numbers, there are no common divisors except the 1 and the number itself. So in case we take two different prime numbers instead of 12 and 9, and we went on to find the GCD of them, so we will always get 1 because there is no other common factors between them except for 1. And this is also a formula which we all have studied in the school, which says that the product of LCM and GCD of a pair of numbers is same as the product of both numbers. In this way, we can also find LCM after we find GCD on the basis of this formula. So, as in every video, we discuss the brute force approach first, then we go for the optimal approach. And in this video, we will also do the same way. So now let's start the brute force approach and how can we solve this problem using brute force. So the algorithm is basically we have to run the loop from 1 to minimum of n1 and n2. Why minimum of n1 and n2? I will say later. And if the iteration variable or I divides the both the numbers, then that means that I value or the iteration value is a divisor or a common divisor of both the number. Then initialize a GCD variable before the loop and assign the I value to the GCD and continue until the end of the loop. And after the end of the loop, we would have got our GCD value in this variable. Now, why I took min of n1 and n2? Because as you can see, after this example you consider, the factors of 12 are 1, 2, 3, 4, 6. And in the factors of 9, we have 1, 3, and 9. Can you notice one thing? After all the factors of 9 are or all the factors of 9 are evaluated, we don't have to continue the loop anymore because after the smallest number is crossed, we cannot get any common divisor between them because the number itself can be the common divisor between them. After that, we cannot get any common divisor between both the number. Suppose if we have 12 and 9, we have to continue the loop till 9 because if we go for 10, we can't get any common divisor between 12 and 10 because our task is to find the common divisor between 12 and 9. So why would we go and check the common divisor between 12 and 10? Understand my point? So that's why it's important that we have to apply a condition and restrict the loop so that it calculates the GCD until the minimum of n1 and n2. So the code is pretty simple. First, we have to initialize a GCD value. And for every two numbers, the initialized GCD value is 1 because in case they are prime number, their GCD is always going to be 1. So we can initialize the GCD value with 1. We can also initialize with 0, no problem. But it's a general convention to initialize it with 1. Now we have to run the loop from 1 till minimum of n1 and n2. And then at any case we get a value that is dividing both n1 and n2, then that means that I value is a common divisor of both n1 and n2. Then that means that value will be assigned to our GCD. Then we again continue our loop, and then we again continue our loop to find if there is any more factor that is greater than this GCD. Then again we will assign that I updated I value to the GCD, and the algorithm time complexity is minimum of n1 and n2 because our loop is running till minimum of n1 and n2. So let's code this problem out in the lead code problem. So what's our problem? The problem is to find greatest common divisor of array. We have a array and we have to return the greatest common divisor of the smallest number and the largest number. So we have to find the smallest and largest number in the array. So for this, we will use a predefined sorting function in Java that is available in the arrays class, which is available in java.lang package. So then we will sort the array. We will pass the array variable in parameter. Then our first number will be the lowest number in the array. After we sort the array, the element at the zeroth index will be the lowest number, and the element at the last index will be the. And we have to run a for loop from 1 till minimum of. Uh, so in this case, we don't have to run the loop till minimum of A on B because we already know which one is the minimum. Here, A is the minimum. So in cases where we know the minimum number, we don't have to use that minimum function or any other operation which is used to calculate the minimum because we already know the A is the minimum number after we sort the array in ascending order. And then I plus plus. Then in any case, the I divides both A and I. The I divides both A and B. Then in that case, we have to update the GCD value with I value. Then at the end of the day, we have to return the GCD. Now let's run this problem. As you can see, all the test cases have been accepted. And let me submit the code. As you can see, the runtime is 2 milliseconds, and it's uh, it's only better than 40% of the solution, 43% of the solution. That means we can improve it. There is a scope for improvement, and we will see that in the optimal approach, how to do that. So let's go for the optimal approach. Before optimal approach, there is a better approach, which is like an intermediate between the brute force and the optimal approach. So in the better approach, we just have to do the same thing as brute force approach, but we have to run the loop from minimum of n1 and n2 to 1 because as you can notice, the GCD value is always a greater value. It's closer to the minimum number than to 1 for most of the cases. So if we apply that in reverse order, we have to just find out the GCD and then we have to return it because the first GCD that we got is will always be the maximum value of the GCD. Getting my point? So let me explain you with the previous code. Suppose 12 and 9 are there, and we have to calculate the GCD of 12 and 9. In the first approach, we are going from 1 till minimum of 12 and 9. That means we are going from 1 till 9. So first we got GCD as 1, then we continued the loop, then we got 3 as common divisor, then we continued the loop again, then we reached minimum of 12 and 9, that's 9. Then after that, we stopped the loop, we got the maximum or the GCD as 3. But if we do that in the reverse order, we iterate from minimum of n1 and n2, that is 9 till 1. Then the first GCD that we got will always be the GCD of the both the number because after that we will only get the lowest common divisors, but actually what we need is the greatest common divisor. So in the reverse traversal, the first common divisor that we get will always be the GCD of both the numbers. So let me optimize this solution with the better approach, and let's see. Int I is equal to a I. Uh, we have to run until I is greater than is equal to 1, then I minus minus. Then the moment we find the GCD, we have to return the GCD. And here we have to return minus 1 because if we don't return anything, it will show an error. So we have to return a minus 1, but this code will be never accessed by the this method because it will always return the GCD value because in any case, even if there is no common divisor, the GCD value will be 1 in case of prime numbers. So let me run it and check if the output is running fine. Let me submit. As you can see, it beats 83.13% of the people. That means it's slightly better than the previous approach, but still it's not the most optimal approach because in the worst case, the time complexity is still the same. The worst case is what? When the both the numbers are prime, then the GCD of them is 1. Then it doesn't matter when we are coming from the reverse order, we still have to traverse all the way from minimum of n1, n2 till 1. So the GCD value will be 1. The time complexity is same as the brute force approach. So let's move into the optimal approach and understand it. The optimal approach is nothing but the Euclidean algorithm. which we all have studied in the school. And let me just remind you the what was the method that we have studied and how can we apply it to find the GCD of a number in programming. So the Euclidean algorithm says that we have to divide the number or the both numbers given with each other, where the smallest number or the smaller number will be the divisor and the greater number will be dividend. Then what we got in the remainder will be the divisor for the second iteration, and the divisor from the first iteration will be dividend for the second iteration. Getting my point? And how for how many time we have to continue this loop? We have to continue this until we get n1 percentile n2 is equal to 0. So observe here. We have 36 as n1. It is a bigger number, so we take it as dividend. And we have 24 as divisor, which is the smaller number, n2. That's why we have taken it as divisor. The quotient is nothing but n1 by n2, and the remainder that we got, that is n1 percentile n2, that is 12. So our remainder n1 percentile n2 will be the divisor for the second case. What is our divisor? Our divisor is 24 or n2. So the remainder will be equal to n2 for the second case, and n2 will be n1 for the second case or the second iteration. N2 or the divisor will be dividend for the second iteration. N1 percentile N2 or the remainder will be the divisor for the second iteration. I think my point is clear. And how until how many steps we have to continue this iteration? We have to continue this until N1 percentile N2 is equal to 0. So as you can see, I have noted down the points. Loop till n1 percentile n2 not is equal to 0. Remainder is equal to n1 percentile n2. In every step, we count the remainder. Then we assign the value of n2 into n1 for the next iteration, because the n2 or the divisor will become dividend in the next iteration. And we assign the remainder value to the n2 because the remainder will become divisor for the second iteration. So now let's code out the problem with the optimal approach. So in the optimal approach, we don't need any GCD variable. We just need the a and b value, and we have to just calculate the recursive divisor and dividends until that both of them the quotient does not becomes 0. So until the quotient does not become 0, we have to calculate the remainder for every step. The remainder is nothing but a percentile b. Then we have to assign the uh, we have to assign the divisor value to the here. As you can see, in the next step the divisor become the dividend, so we have to assign n1 is equal to n2. So that's what we are doing here. In the next step, the current divisor becomes dividend. So in this problem or in this line, we are actually shifting or adjusting the value of divisor and dividend for the next iteration. And what will be the divisor? The divisor will nothing but the remainder of the problem of the current iteration. And what will be our GCD? The GCD will be nothing but the divisor after the a percentile b becomes 0. So let me submit this solution and check if it is, sorry, we have to return b. I accidentally wrote int b. So that's why it's getting a compile time error. So as you can see, all the test cases have been accepted. And as you can see, the runtime is less than the previous approaches. So as you can see, this algorithm. So what will be the time complexity of this algorithm? So we have to analyze it step by step to calculate the time complexity of this algorithm. So the time complexity of this algorithm will be logarithm of minimum of n1 and n2, because in each iteration it reduces the problem size by replacing the larger number with the remainder of the division. So the number of steps is proportional to the number of digits of the smaller number. So if we go for the calculation of the time complexity, it will become complex. So I'm just explaining it verbally. So the time complexity will be log of minimum of n1 and n2. In case we have to calculate the LCM of the problem, or the LCM of the given number, we can just apply the formula. Int LCM will be nothing but GCD divided by product of both the numbers. So if we submit this, we will get an error because it does not ask for an LCM. So you can definitely do that if the problem asks you for it, and both of them are related. And that's it for this video. I hope you like this video. In case if you have any doubts or queries related to this video or any previous video, you can definitely reach me out in the comments. I will be happy to answer your questions. Till then, keep learning. Thank you.